So the next thing I want to do is to get a joystick working on my XI8088. Back in the day, I had a Tandy 1000. I fondly remember playing old Sierra games like the King's Quest and the Space Quest and Hero's Quest before it was renamed Quest for Glory. And back then I had a joystick. In particular, I had a Tandy Deluxe joystick. This is not a Tandy joystick, this is a Kraft. But to the best of my memory, it looks just like a Tandy joystick, but with the word Kraft on the front. There are some internal differences. We'll get to those later in this video. So you need a joystick. You also need a game card for an original PC. There was no USB back in those days. We had analog game cards. So this is an analog game card here. This is a Kraft. I bought both of these off of eBay. So looking at this thing, we've got, it's got two DB15s, one for each joystick. I think you can actually run two joysticks with a splitter off of just one port, but they must have decided better to have two ports, and you can just plug two joysticks in. I believe the way these worked is that they used a capacitor and a potentiometer inside of the joystick. The capacitor and the potentiometer, together with a timer chip that would, based on the position of the pot, would give you various intervals of pulses output from the timer chip. And you could time those pulses in your computer, and you would know where the potentiometer and the joystick is at. Looking at this thing, we know this thing must support 4 potentiometers, an X and a Y for each joystick. I do see 4 green capacitors there. I see 4 little disc capacitors next to them. I see a NE558. I'm going to gander that maybe that is a timer chip. So let's, I'm going to put this in and try it out. One difference is that the connector has a DB15 like a PC game card uses rather than a DIN plug like the Tandy 1000 used. So by buying the Kraft instead of the Tandy, I could get one that would plug right into the PC game controller card without having to build an adapter. Another difference is internal, and we'll see that in a moment. It has to do with how the potentiometers are hooked up. But anyway, I tried this out and I had 2 problems with it. First of all, in a couple of the places I tried to use it, in King's Quest 4 and in GW Basic, it wouldn't work at all. GW Basic, there's some commands that will let you query the status of the joystick pots and the push buttons, and none of it showed anything. King's Quest 4 just refused to acknowledge it. King's Quest 1, I was able to get it to acknowledge the joystick, but it only worked in the X direction, and nothing worked in the Y direction. And then also worked in Arkanoid, but Arkanoid, there was only an X direction, there wasn't a Y direction to test. So that seemed like 2 different problems. I figured I'd tackle what seemed like the simpler one first, which is that only the X direction was working, not the Y direction, because that could be a mechanical or electrical problem. First thing I did was I looked at the DB15 and made sure that all the pins are present, they're not bent, damaged, broken, something that would be obvious to fix. Then I hooked up my multimeter to the joystick so that we can read the pots. So pins 1 and 3 will get you the X joystick. So pin 1 is I believe it's a 5 volt, and pin 3 is the output of the pot. So right now in the center it's reading about 47 kilo ohms. There is a trimmer, you can adjust that. So we could adjust that so it's exactly 50 kilo ohms. If we move all the way, as we move it to the left, the pot is going down, reading lower and lower and lower. And now we're at 210 ohms, which is probably just about as close to 0 as it gets. So going back up to the middle, we're back around to about 50 kilo ohms. Going full to the right, they're up to 115 kilo ohms. So this is, it's ballpark on a 100 kilo ohm pot. Obviously, you know, moving the Y one, there's some mechanical difference just because it's, you know, I'm moving something that's a mechanical assembly, but, you know, the different pot for the Y pot. So now if we go over here to pin 6, there we go. Y potentiometer is reading 42 kiloohms. Move it up, move it down. It's kind of doing a little something, but not a whole lot. If we move the trimmer adjust isn't doing anything. Okay, so let's take a look at this and see what we've got in here. I've already taken the screws out. So first let's look at the X. We know that's working right. You know, we can see it turns this little ball thing in here. And then the potentiometer itself, the body is fixed, the shaft is turning. Let's try the Y potentiometer, and I think we'll see what the problem is. See, when we do the Y direction, the entire potentiometer turned. Obviously that's not going to read anything, because the shaft is not turning relative to the potentiometer, the entire body's turning. You probably can't quite see it on here, but I will try to take a close-up on the website. But there's actually two little plastic discs. One is attached to the potentiometer body, one is attached to the trimmer control. And it looks like what they did when they manufactured this, they took something hot like a soldering iron and they melted a little spot that fuses the two discs together. That little melted spot has become unmelted, and now the potentiometer is able to rotate free of the adjuster disc. So I think all I need to do is take a soldering iron tip or something and just melt that, and I think we'll have it working. So I took my soldering iron, I fused two new spots in there. These two discs are now hooked together. So if we turn it, we can see that the potentiometer body is no longer turning, it's holding in steady. I'll show the multimeter in a second, but it's back working again. And the trimmer control adjusts from the front. Trimmer control does work. So I said I would mention what the other difference is between a Tandy and a PC joystick. And we can see that while we're looking at this here. I haven't verified this, but this is what I've read on the internet. We can see that on the PC joystick, there's two positions hooked up to each pot. One of those positions is the 5 volt, and the other is the wiper of the pot. The third position on the pot is left empty. That's on a PC joystick. On a Tandy joystick, you'll find that the third position is hooked up to ground. So what that does on the PC joystick, you're just getting a potentiometer output. On the Tandy joystick, this is actually functioning as a variable voltage divider. But just be aware, if you want to use a PC joystick on a Tandy, you'll have to solder these two to ground. If you want to use a Tandy joystick on a PC, you'd have to go in here and you'd have to cut the wires that hook the ground to each of those. Okay, so let's put it back together and see if it works. Okay, so I've now reassembled the joystick. We're still hooked up to pin 6 on the joystick connector. It's reading 48K on the Y pot. We should try the trimmer. Trimmer's working, so let's trim it up to about 50K. And if we push this all the way up, value goes down until it's at 110 ohms or so. That's, you know, effectively 0. Going back to the middle, we're back around 50. Going down to the bottom. Bottom of the pot, very bottom, is a little bit goofy, but it seems to read around 110 kiloohms. So again, you know, ballpark 100K pot used for the Y potentiometer. So I think we have fixed it. So the bench supply's on. You might notice in my previous video the XI8088 probably was not in a case. It's now in a case. I built this oak case out of oak boards from the big box hardware store. Wired the switches to the front, power switch, turbo switch, reset switch, floppy drive. Let's turn on the XI8088. King's Quest 1. Look, it has auto-detected the joystick. It says, please center your joystick. Press enter when it is centered. There. I pressed enter. Any key to continue. There's King Graham. He can walk right, he can walk left, he can walk up, and he can walk down. Well, that's a whole lot better. Whoa! And he can walk into the water. I was just going to say how much easier that is control with the joystick than the keyboard, but then I killed King Graham. Bummer. So it's, you know, it's working in King's Quest. But if we try out this basic program, let's see if that works. MISC. So if we do DOS, basic, MISC. This is a test program that I found somewhere on the internet. Joystick Dayton. But yeah, we can see, you know, joystick not working in GW Basic. So this was the other problem we had, is that sometimes the joystick doesn't work at all. And I think what's going on here is that there's actually a BIOS function for reading the joystick. And I looked in the BIOS for the XI8088, and it does not have that function implemented. So if you make GW Basic makes the BIOS function called read the joystick, nothing's happening. So we need to implement that function call. Okay, so we know that the BIOS doesn't include the joystick subroutine. So what I did was I went out on the internet. I found where someone had disassembled the BIOS from a PC XT, and I took that BIOS, found the joystick routine in it, and I have hacked that to go into Sergey's XI8088 BIOS. And before we try this out, I think you know, it helps to try to understand what it's doing. So looking at the start here, 201 hex, we're going to guess that that's probably the address of the game port. This function is going to take in AL, either a 0 or 1, which is going to say either to read the switches or to read the potentiometers. If it's read switches, we go down here to this routine. This looks fairly simple. All this is doing is just doing an input on that port 201, anding it off so we only get the high bits, and then we jump back here, which is going to enable interrupts and return. So reading the switches, very easy. Reading the potentiometers is going to be more complicated. So that's down here in this Joy3 function. So we're going to see that this reads each potentiometer. So this first time A, X, and Y, joystick 1, B, X, and BY, that's going to be joystick 2. So it's going to call a function for each one of those, setting this BL to a different bit for each one of those. So 1, 2, 4, 8, that seems like a bit mask that's going to test a particular bit on the port. So it's going to call this test chord function down here. So looking at that, it's using the programmable interrupt timer. The The programmable interrupt timer is the 8254 chip. Presumably channel 0 has already been set up by the BIOS. So what this is doing is register 3 is a control register, so I think this is saying setting up the control register to use channel 0. We're just going to read the count that's currently in channel 0. Both the low byte and the high byte of the count. Save that count. Then it's going to set something here to 4FFH. It's probably going to be a loop counter. Going down here. Fire the timer. So if we remember right, DX is still set to 201 hex. So this here I'm betting is going to start that 558 timer. Probably any write to the port probably does that. Probably doesn't even matter what's in AL. The 558 was a quad timer, so there's probably 4 timers in it, 1 per pot. We know that each joystick has 2 pots. Then we're going to go down into a loop here. This loop is going to be reading from the game port, which is port 201 in DX. Then it's going to test the bits in that port for the mask it's set up in BL. If you remember back here, based on the joystick, for joysticks A and B, the X and Y, Z, for joysticks A and B and the X and Y pots, put either 1, a 2, a 4, or 8 in BL. So that is going to be testing for a specific bit to be changed on that port. I'm betting there are 4 lines from that port hooked up to that quad timer chip. So that's going to fire off the timer and then wait for the timer to complete. Okay, so what this here looks like this is going to do is this is going to check for timeout. Remember it said CX to F to 4F. It set CX to 4FFH, so if we counted 4 FF cycles and this timer never changed, then we're going to assume, you know, maybe no joystick is connected or something like that, and then it would exit. So if it is, if the timeout didn't happen, then we're going to go down here. We're going to read the counter timer chip. So all the time that we were waiting for this joystick pot timer value to change, the 8254 was going ahead counting in its counter register. So this is going to read the counter register back in. It's going to do a bunch of stuff down here that is accounting for wrapping, you know, in case the timer overflowed, stuff like that. Then it's basically going to do some adjustments and some shifts and return how many counts occurred. Okay, so let's try booting up again. I've reflashed the ROM in the XI8088 with a new version that has that BIOS function that I just showed you. Let's turn it on. So let's MISC DOS GW basic MISC. Run this basic program again. Okay, this is looking much better because we have some values for the X and Y axis. Got my joystick kind of a little bit off screen down here to the bottom. Let me try moving it to the left. See the x-axis going down, to the right, x-axis going up, up, y-axis got lower, down, y-axis got higher. Working like it should. I'll push the red button. It says button A is on and off. Push the black button. Button B is on and off. Okay, so fixed it. That's definitely what the problem was with GW Basic, was that missing interrupt function. So there we have it. This should be a fully functional joystick and game port now. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.